Okay, lots more division coming up. I'm going to get the fraction 1/2. I'm going to change that into a decimal. So it's how many 2's go into 1. I'm planning on going to decimal places here, so I put my points in already. So off we go. How many 2's go into 1? Well, that's none. We've still got the 1 left over, so I'm going to carry that. 2's into 10 go 5. Anything left over? No. So at that point, because we've got nothing left to carry, we don't need to continue. Everything's worked out nicely. This has stopped, it's ended. And so we call it a terminating decimal. That means it finishes, it stops, like a bus terminus, somewhere where it ends, or a terminal, airport terminal, or more famously, the Terminator kills people. He ends them, basically. So there we have a terminating. If we then get 1/3, so 3 into 1, I'm going to do the same thing again. I'll leave myself some zeros, put my point in. 3 into 1, doesn't go still. Well, it's too big, isn't it? So I carry the 1. 3's into 10 goes 3, because 3 3's are 9. 1 left over. 3's into 10 goes 3. 1 left over. 3 into 10 goes 3. 1 left over. And I could, if I had absolutely no time on my hands, too much time on my hands, I could do that forever. But I'm not going to. As you can see, you've got a repeating decimal. That's called recurring. And there's a much easier way to write it than just going 3 3 3 3 3 3 3 3 3. I could just put 0.3 with a single dot above the 3. That means it's going to repeat the digit that the dot is over. So there we have it, a terminating and a recurring decimal. And it doesn't stop there. So how many 4's into 1? Let's write this down carefully. 4's into 1 won't go. Carry the 1. 4's into 10 will go twice. 2 4's are 8, that's 2 left over. 4's into 20 go 5, none left over, so I can finish. What type of it's a terminating decimal because it ends. So I'm going to put T next to that one because it's a terminating. And now I'm going to go for a 5th. 5's into 1 goes none, carry the 1. 5's into 10 goes 2, none left over. It's stopped again, it's a terminating. Let's go on to a 6th. Hopefully something interesting is going to happen there. 6 into 1.0. 6 into 1 won't go. Carry the 1. 6 into 10 goes 1 with 4 left over. 6 into 40 will go 6. 6 6 is a 36 and 4 left over. You see the pattern now? 6 into 40 will go 6, 4 left over, and again I could keep going forever and a day. That's a recurring decimal. I can write that as 0.1. Now the number that's repeating is the 6, so I just put it over the 6. There we have it, on to 1/7. And on we get to 1/7. You could do all of these yourself and check with a calculator, but watching this carefully now, we're going to say how many 7's go into 1. A bit of a clue here that I've left a lot of space. So I'm going to put a few zeros down, and off we go. 7's into 1 won't go. 1 left over. 7's into 10 will go once. 3 left over. 7's into 30 will go 4. 2 left over. 7's into 20 will go twice, that's 6 left over. 7's into 60 will go, come on, do this, I don't want to do this all on my own. 7's into 60 will go 8, 4 left over. 7's into 40 will go 5 and 5 left over. 7's into 50 will go 7 and 1 left over. 7's into 10 will go once and 3 left over. 7's into 30 will go 4. Now if you notice, I'm getting the same numbers coming up along here. So I've already got 1 4, my next digit would be 2. So now it is repeating, but it's repeating in a different manner. So I'm going to show you how to write that down. We've got 0.142857. Now, at that point we get the 142 coming back in. So I have to put my dots. We put the dots above the first and the last number that repeats. So this would actually read as 0.142857, 142857, 142857. And there you have it, a recurring decimal written a little bit differently.